In this video, I'm going to explain how to use z-scores to make informed decisions. First, the thing to notice about z-scores is that any score that has a negative number indicates that their relative position, score of 54 compared to the mean of 37, is 2 standard deviation units below the mean. In the case of scores that are where lower is better, you can tell that a score of 54 is higher than the score of 37, or it's slower than the score of 37 seconds. In contrast, when the mean or the unit of measure indicates larger scores are better, like on the confidence questionnaire, you'll notice that negative scores will be associated with lower numbers. Negative z-scores will be associated with lower raw scores. In contrast, positive scores, like in the case of 0.7 here, where we have 345s, or four people who scored 45, they have the same standard deviation of 0.77, indicating they are 0.77 standard deviation units above the mean because it's positive. So the practical utility of z-scores is that you can sum them, and because all of the scores are standardized around the mean of a z-score by definition is 0 and the standard deviation is 1. And if you look across, you'll see that the standard deviations and the means are as defined. Standard deviation 1 and a mean of 0. And due to rounding, they're not perfect. So what you do next is, if you want to choose the smartest or the best athletes, you choose what variables are important to make that decision, and you simply sum the z-scores. And the person with the highest score is the best relative to all of those variables considered at the same time. So let's say you're selecting a basketball team and you want someone who is tall, you want someone who behaviorally follows the rules, if that's something you have scores on. Oops, you gotta make sure you're collecting the correct scores. So make sure you take the z-scores, not the raw scores. You want someone who's confident, and you want someone who knows your playbook, and someone who is fast. So once you have those numbers, you simply sum them, and this is a z-score, and you drag it down, and you can see that you have a range of scores. Most of them are on the positive end, but in order to find the, let's say, top 10 athletes, you'll want to sort, so you can highlight that. Now, keeping in mind, you do not want to include the dummy variable, so actually we'll just delete that for now. And then you can sort these numbers from largest to smallest. Select sort, and there you have your top 10 athletes. So this is your best athlete, and it corresponds to student number 10. They will have relatively the highest scores across all the variables you chose, followed by your second best student, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So if you were to select a basketball team, let's say, these would be your top 10 students. And of course, they wouldn't be numbered. You would have names associated with them. But those would be the phone calls you make. Student 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's how you use scores to make informed decisions.